Our expert presenter today is Stefano Rizzo, Senior Vice President, Strategy and Business Development with Polarian Software. In his career, spanning some 20 years, Stefano has been a methodology consultant and CEO of 2 software development organizations. With his broad experience in ALM, he has been the leading product management for Polarian Software product line in its first release in 2005. In his current role as SVP, and in addition to defining the corporate vision, he leads several research projects in both ALM and the PLM fields. Please welcome Stefano.
Good morning, good afternoon, and good evening to everybody. Today, we will go through a presentation about ALM and PLM going together. This is actually the first time ever in which we at Polarian Software introduce this kind of content. Actually, is part of a pretty long research activity that landed into the creation of 2 white papers and this presentation today. What we will discuss is a brief introduction about what are PLM and ALM and try to understand the reasons why they should come together. Stated that we will see which are the challenges in creating an integration, and then we will propose a possible solution and approach that we call PALM. So in this introduction, we will speak about a bit PLM and ALM. Actually, this is me and my email address. You can take a note. At the end of the presentation, if some question will arise later in the next days, eventually after reading the white papers or some feedback, I will be happy to answer and to gather your feedback. So what are ALM and PLM? Actually are 2 different sets of disciplines tackling the need of developing software and developing products. Taking a deeper look inside ALM, we can find some disciplines inside that we can call steps. So this is not an exhaustive listing, or it's just one possible topology of different disciplines. Many are proposed in the literature. To address software development, we have disciplines like application project and portfolio management, project inception and requirements gathering, requirements management through all the process, design, coding, testing, QA, build, release, deploy, application performance. All these disciplines contain different steps, different methodologies, and sometimes involve different tools. The same is in PLM. Also, we have steps, and in an even less exhaustive listing, we can see that we have a conceive phase when we create a product, when we get the idea, when we define the concept of a product. Then a very wide design area that is divided in several different steps and involving different tools and people. Then we create the physical product, and then we service the product. So in general, the key difference between ALM and PLM is not the fact that they are divided into phases, but how these phases are orchestrated. In general, what we have is that the PLM approach to product lifecycle that you see on the left is a typical process that from the concept to disposal is a sequence of steps that occur normally only once. So iteration inside PLM, inside product development is a kind of concept which is not really so possible. So a product comes from a concept, is designed, is prototyped, is launched, is in production phase. Then there is a pretty long service and support phase, and then phase out and disposal. In ALM, agile methodologies, but before agile methodologies, while developing software code, while creating software, became iterative pretty soon. So the life cycle is a continuous development, a continuous refinement of software involving phases like requirements definition, test, change, configuration, task management several times. many times, iteratively. Through the time, the product becomes more and more refined. So this is one big difference between PLM and ALM approaches. But we recently realized that ALM and PLM must get together. There is a big pressure to have the two different tool sets more integrated, more close each other. And the reason for that is because we see more and more in the market that software is driving the innovation. There is more and more software inside devices, inside cars, inside any kind of physical product that we are creating. And we see also that the need of the increasing number of lines of code that are embedded in each single device is increasing and increasing. So in many cases, we've been dealing with software inside hardware devices like a part, like a component, like any other component of the product that has a kind of life cycle that once tested and once plugged on a chipset, plugged inside the product, can be treated as a part. But it's widely recognized that software is the dominant driver of industrial product innovation. There is a lot of innovation in our products that is driven by software. So engineering phases, in engineering a complex product, there is more and more effort that is spent around software, and it's increasing every year. So there is a key need that software engineers and hardware engineers, product engineers, system engineers in general must work together, must share common resources, must communicate and collaborate to deal with innovation, to create faster innovation in the market, and to become dominant in their respective marketplace. But which are the challenges? So stated that ALM and PLM must come somehow together, we have for sure to address some challenges. The big question is the big challenge a physical integration issue? Is the problem a problem of having a tool set which we call PLM? We have PLM tools, and we have a tool set or a set of tools that we call application lifecycle development. Is really the problem to create a physical integration? Is that so difficult to put the two products, the two environments together? Actually, my statement is that this is not really an issue. A modern technology, modern ALM, modern PLM system are pretty open today. Creating a physical integration means putting a link from a component, from a hardware component, from a PLM part to a software piece of code, to a piece of code in ALM. This is a kind of pointer, this is a kind of link that we must be able to travel in the two directions from ALM to PLM and vice versa. Is this really the issue? Actually, no. It's just a matter of putting pieces together. Means that if we have 20 ALM tools and 20 PLM tools that we need to integrate them all, we will need to run through 400 integrations. It's just a matter of time. It's just a matter of developing some code to make the integration happen. But this is not the key challenge today. This is not really the issue today. It's more a logical issue. So it's not a matter of putting ALM tools in contact with PLM tools. Of course, this will be more and more easy if we have less tools to integrate. And that's the case of Polarion, of course. In Polarion, you have a complete ALM solution in one single platform out of one single product. In that case, integrating that with your PLM tools will be even easier because you have just one point of contact. But in any other case, it won't be a physical integration issue. The real problem is that we are running through a logical distance. The PLM manages components and manages approaches and methodologies that are logically different from ALM items, ALM files, ALM approaches, ALM processes. So just to give you an example of few logical differences. We have that in one case, in the PLM case, we manage parts, and in ALM, we manage files. It's conceptually, we can say that the part is written in a file, yes, but we are managing physical components with a life cycle, with a life that comes from production to disposals, and it's physically the same through all its life. Through all the parts' life, the parts will remain the same. While a file is subject to change daily or very frequently. So a file, a software file, an application file is a completely logically different item to be managed by ALM compared to parts managed by PLM. Even more interesting and deep difference is the fact that we manage functions and components. In PLM, we manage a component is by itself a kind of piece of steel that has a kind of function, So a screw, for example, is a piece of steel which function is to fix two different pieces of hardware. The function is the component itself. The component implements a function, while in software we envision, we define, we describe functions that can be implemented in many different ways. So we need a function, we need an algorithm that sorts all the items contained in some database. So that make a sorting of the items. And this is the function we need. This is what we need. And there are several different ways in which we can implement that. So the function will survive even when the technology will evolve. In the case of PLM, we don't have the ability to say we need something that keeps two things together. We say we need a screw to do that. Another important difference is about links. All the items, both in ALM and in PLM, must be linked together. In PLM, we mainly manage links that are of the kind part of. We have a conceptual decomposition of the problem of the product into parts. So a product is decomposed into parts, which are decomposed in subparts and so on. And the relationship that exists from a component and its subparts is a part of relationship. In application lifecycle management, we have several different types of connection between the items that we manage. So, for example, we have that a piece of code implements a requirement. So it's connected to a requirement with a relationship which is implements. We have that another piece of code fixes a bug, so resolves a problem. So the connection between the bug and the line of code that we change is fixes. But we have many others, not just related to code, between different application lifecycle management work items, such as from requirements to test cases. A requirement is verified by different test cases, and so on. So we have that traceability inside ALM covers different traversals of a graph. So we can go through a complex graph in ALM, moving from one component to another component, following several different link types. This is not normally possible in PLM systems that manage just a part of decomposition. Another key point is the information that is connected to items. In PLM systems, we have that normally the information that we store together with items is pure mathematics. Is tolerances, is formulas, is diagrams, and in ALM is much more descriptive. So in PLM we have precise mathematics connected to parts, to components. In ALM we have, for example, a textual description which is connected to a requirement. We have mock-ups describing a user interface, for example. We have user stories, we have test scenarios. So another key difference between ALM and PLM is in the information that we store together with the different items, so on parts or on files. Then we also manage different models. In PLM, with our CAD, CAM, CAI system, we have normally layers. We manage several different layers. In application lifecycle management, we have models which are functional decomposition, again follow functional decomposition of the problem, so entity relationship, UML, and so on. It's getting deeper inside these logical differences makes it crystal clear that it is not possible to use today a PLM system to manage software development, and it's not possible today to use an ALM system to manage product development. So the two questions that we are trying to answer in these days are, do we really need to put ALM and PLM together? And the answer is yes. The market is asking that. We need to put ALM and PLM more closer because engineers need to collaborate. Software engineers and system engineers need to collaborate. This is the first answer. The second question is, can't we use a PLM system to manage software development? We've been using PLM to manage everything in the past. Why cannot we manage also software development with the PLM system? And the answer is no again, because there is a logical distance between the two systems. There is a set of deep logical differences that make this action not possible today. More details about this are contained in one of the two white papers that we published, and I will give you the names and the links at the end of the presentation. This white paper covers the part why ALM and PLM must go together, and which is the reason why you cannot use PLM to manage ALM or vice versa. So we've been looking into the challenges. Now let's introduce our proposed approach to make ALM and PLM more closer coming together. The approach that we propose is called PALM. Well, the acronym is not that new, and I'm not sure if it was so successful in the past. The acronym is not just saying taking the P and the A out of PLM and ALM and putting them together, but is the idea of creating a common process backbone that is connected, is deeply connected to ALM, is deeply connected to PLM, and contains all the disciplines that are useful both in system engineering, in product development, and in software engineering and software development. The disciplines that in this PALM backbone, which is actually a piece of code that provides some features that are commonly available to all the engineers in system development. All engineers that are involved in a product development, both software engineers and hardware engineers. The disciplines that must be concentrated in this common backbone that we call PALM are process management disciplines, so the ability to manage the different steps in software and hardware development together in one single place, because in one single place we need to share one common process now, and all the collaboration features to make engineers collaborate with each other and able to create new technology, to create innovation, collaborating both in hardware and in software. Requirements and traceability management, so the ability not just to define requirements which are user requirements, but all the specifications that we manage in the process. So both software and hardware specifications coming from user requirements, coming from the corporate strategy, down to all the specifications, all the formulas, all the textual material that we manage must be contained in this shared platform, this conjunction platform. And quality assurance. Quality assurance, which is not just testing, is, of course, testing, is also risk management, is all the acceptance criteria, acceptance test, system test, integration test, software test, hardware component testing. So these are the four macro areas that must be covered by one single tool set in the company, which is in deep conjunction both with ALM and PLM. Just a little bit more deeper, we want to create a common repository. So Palm is a common repository where all the common assets reside. All the assets that come from the collaboration of people. Of course, the Palm backbone must be able and must encourage collaboration of people, versioning, ability to version all the test cases, all the requirements, all the specifications, all the discussions, and ability to drive the change, to manage the change. When a change happens, being able to go through all the traceability links, to find all the components that are impacted by a change, and also be able to perform the change and be sure that I've been changing everything that I needed to change. About workflow support and processes, it's a wide area that would need one separate webinar at least. But the idea is that good companies, good practices, good approaches must be governed by a system, must be governed by a tool set, not by people. I mean, once a process is in the hands of people, I mean, when our engineers that must know and learn which is the next step I need to perform after step X, we will have mistakes. We will spend a lot of time in teaching people new processes, in having people involved in managing the processes, instead of creating innovation, which is their job, instead of creating the product or the software they are intended to do. The Palm backbone must be able to drive people through the process, must be able, is the Palm backbone that knows the process, that drives people through the process. So once you perform a task, once you complete an activity, next activity is suggested, is driven by the tool set and not by the people's knowledge. So we will be able to perform process improvements. We will be able to test changes to the process, because we will not need to train people again and again, but this will be just a matter of changing some few configurations in the Palm backbone. Traceability, quality assurance, testing, as I said before, are the other components that must be common in this platform. So what is Polarion today? This is our proposition. Polarion is, as I briefly said before, is one single ALM system, Application Lifecycle Management System, that contains in one single product both requirements and tests and change management activities, task build, audits and metrics, and plus full process support, ability to comply to different processes. And we have plenty of customers in different vertical markets. Most of them are in the system engineering sector. So a large majority of our customers is working in creating not only software, but software which is embedded into hardware systems, which is connected, deeply interconnected with devices, especially in the medical industry, in the aerospace, automotive, defense, and manufacturing. We've been more and more adding features for the collaboration, for the requirements and traceability management, for the quality assurance, more and more features to our platform that today make Polarion the first Palm backbone, the first Palm solution in the market. In this picture, as you can see, except of build management and maybe audits and metrics, all the other features are features that are useful both for software and hardware development. So today, Polarion can be considered the first Palm platform in the market. Actually, there are some few reasons for that, beside the infrastructure that we've been creating, beside the technology that we are delivering. One good reason to consider Polarion as your PALM solution is this is actually a one single product. It's an open ALM, so it's an open platform ready to be integrated, out of the box integrated with many technologies that are not just in the software development industry, but also in the product development industry. One case, for example, Simulink and MATLAB from MathWorks, but many other modeling environments, for example, and PLM components and PLM systems. It provides, out of one single product, all the features that you need in ALM, plus all the PALM features ready for any PLM. So all the collaboration features, all the versioning, change management, quality assurance, risk management, and traceability and forensic reporting features. Polarion is also available. It could seem strange, but Polarion is a product that is already serving customers in the system engineering sector, providing integration between ALM and PLM. Is not just a promise for the future, like many of our competitors like to do. Is not something that will happen tomorrow. It exists. You can download that. You can use that, and it's certified. It's the only trusted tool from TÜV. I guess that many of you already know TÜV certification. If you want to go through a TÜV certification, you need to demonstrate, you need to certify all the tools that you are using. So if you want to certify your product or the technology that you are releasing to the market, you need to certify that the tools that you are using to create the technology are certified. In many cases, our customers had to do that. Now we certified our product, so our customer doesn't need to certify Polarion for a TÜV certification. It's already been certified by us. It's the sole technology in the market recognized by TÜV, which is universally known as the certification authority for hardware devices, for product devices. It's usable. Just the fact that it's one single platform means that, of course, you don't need to jump from one piece of code, from one tool to the other one, but everything is in one place. But over the years, we've been increasing more and more usability in our ALM platform. And we are now, since a couple of years, we are working to provide unparalleled usability for PLM users. So we are building integrations. We are working on integrations, not just on physical integrations. That, as I said, is pretty straightforward and easy, but we are also defining, which are, together with our customers, together with our faithful customers, and with the help of the major industry analysts that are very close to this project, that see that this project is very innovative. Together with them, we are defining the use cases, we are defining the approaches, we are defining how PLM and the ALM will work together, not just physically, not just through a physical integration, but through a logical integration of the processes, of lean manufacturing together with agile methodologies, for example. Thanks to this, we are appreciated and we are recognized as a vision leader by industry analysts, and we are also recognized by customers, industry analysts. As I said, besides collaborating in this initiative, and a couple of them are also listed in the white papers that you can download at the end of the webinar. Some others are not listed because their firm doesn't allow them to be there, but it's a wide research and analyst area behind this job. And Ovum also gave me this nice statement that recognizes the fact that we are really advanced in studying how to put ALM and PLM together. Some customers, what customers said, the first one is something I particularly like. We've been recognized as the Switzerland of ALM. I mean, no matter which PLM system you have today, no matter if you don't have a PLM system and you will have a PLM system tomorrow, Polarion is the right choice for you because it's wide open to be integrated physically and logically with any tool that exists today and that will exist tomorrow. The other statement comes from another big industry customer and says that Polarion has become the orchestra director for our hardware software product development, which is actually what I mean with PALM, a single platform, single orchestra director able to manage both all the disciplines that are common in software development and in product development. So that's all, folks. I think that you've been already told how to post questions. I'm now in front of Q&A panel, and I also have the chat panel open. The Q&A panel could be more suitable for this job. So if you want to post some questions there, I will be happy to answer. In the meantime, I want to recommend you which are the next steps. I promise to give you the link to these resources, these white papers, actually 2 white papers. Why ALM and PLM need each other, which gives the 2 answers why they should get together and why we cannot use PLM to manage ALM and vice versa. And the second white paper, if you're already familiar with ALM and PLM, if you are already convinced that they should go together and they're convinced that you cannot use PLM to manage ALM, for example, you can read the second one, ALM meets PLM the PALM way, which gives more insights, more details of the PALM approach, and also a roadmap of the future, a roadmap that Polarion and all the software ALM and PLM vendors should follow. About following, we are on Facebook, on LinkedIn, on Twitter, and in Google+. So we'll be happy if you will join us. Okay, there is an interesting question, good question. Which commercial PLM tools or mechanical design tools does Polarion currently integrate out of the box? The answer to this question is on our website already. Polarion is, as I said before, is an open platform and shows open APIs and web services. With these open APIs and web services, it's possible to create configurations, so process configurations, plugins to Polarion itself, but also create integrations. All the integrations are shared between our customers. Some of these are provided by us, some are provided by our partners, some are provided by our customers. All these integrations are listed on the POP website, which is the extension website. If you go to polarion.com/extensions or just to polarion.com and look on the top of the page, you find the extensions link. You will find the 150, I guess, available extensions that include also integrations. Another nice question, which is even more specific. Does Polarion integrate with Teamcenter Siemens? The answer is that we have customers that are working with the 2 systems integrated. The integration is a physical integration today, provides some connection between our work items to Teamcenter items, to Teamcenter parts, but we are working in developing more sophisticated integration, which is resolves more logical issues. But the answer is yes, and it's open for your input to let us make it better. Another question that arrived is which kind of industries have you been, are your customers located? So in which verticals? As I said before, we are an ALM company. We come from application lifecycle management. We come from software, but we soon realized that more than the large majority of our customers are in the mechatronics industry. And I don't have a clear graph under my eyes, but let's say the major verticals that in which our customers are automotive, defense, and medical devices, aerospace. I don't see any more questions coming in. So thank you, ladies and gentlemen, for attending this webinar today. And I look forward in receiving your feedback and comments through email on the social networks you see listed on the screen. Thank you, and have a nice evening and morning.